All right, we're looking at this sequence and we want to try to write the function that represents it. So we're going to write, sometimes it's called the rule, but I'm going to go ahead and put write the function. So you have to first determine what type of sequence it is. And for us, we've only really talked about two different ones, either arithmetic or geometric, which are fancy terms to describe how it's growing. Is it adding the same number every time? That would be arithmetic. Or is it multiplying by the same number every time? That's geometric. So I can sort of just do some subtraction here. In fact, I call it the common difference because I'm going to do this number minus that number, and then this number minus that number, and then this number minus that number, and see if I get the same thing every time. So I'm going to do 8.5 minus 5 to figure out how much more that is. Well, it's 3.5 more. I'm going to do 12 minus 8.5. That is also 3.5. 15.5 minus 12, that's also 3.5. So again, that number that we're adding every time is called the common difference. And again, it's called the common difference because we typically get it from subtractions. Difference is the answer to a subtraction problem. So I know that I am adding 3.5 every time, right? This is plus 3.5. This is plus 3.5, so on and so forth. So that's called my common difference. And in terms of an arithmetic sequence, because it's growing by this, adding the same number every time, it's linear. Because it's arithmetic, it's spelled the same for arithmetic and arithmetic. That means this is going to be my general format, y equals mx plus b. So I just need the slope and the y-intercept. Well, good news, the common difference is the slope. It's how much we're growing by every time. It's the growth. So that's going to be my m value. So then really all I need to do is find the b value, find the y-intercept. Now there's a tendency to look at this sequence and say the y-intercept is 5. I'm just going to get this guy highlighted. My common difference is 3.5. That's my m value. That's going to go right here. But the y-intercept is actually the 0th term. We get that when we input 0 for x. This is actually, in terms of my sequence, this is actually my first term. So I have to back this process up, and instead of adding 3.5, I got to basically subtract 3.5. I need to find my 0th term. So I'm going to take my 5, and I'm going to subtract 3.5, and that's going to give me 1.5. My 0th term is 1.5, so that's my y-intercept. It's the 0th term. So now that I know that, I can put all the pieces in where they go into my function, y equals mx plus b, right? This is the b term. It is the 0th term. And I can write my function. Instead of a y, since it does say write the function, I'll use function notation. So I'll do f of x equals. All right, now it's my slope times x. So my slope is 3.5. My slope is the common difference, 3.5x. And then my y-intercept, or my 0th term, my starting value, is 1.5. Now the nice thing about this is I can confirm that this is right by inputting like any term number. Like if I wanted to know my 4th term is 15.5, if I do f of 4, so I'm going to do 3.5 times 4, oops, not times 49, plus 1.5, I'm going to get 15.5. The 4th term is 15.5. If I input 4, I'm going to output 15.5. All right, so this is my final answer. But it's nice to sometimes input a number, f of 4, 3.5 times 4, plus 1.5. So that's going to give me 15.5. And that is telling me my 4th term is 5. Which I can clearly see from the original sequence. 1st term, 2nd term, 3rd term, 4th term is, oh, I said 5. 4th term is 15.5. Yikes. 1st, 2nd, 3rd, 4th, 15.5. I input 4, I'm going to output 15.5. This is the function to represent the sequence. It's linear. Find your common difference, find your slope, find your 0th term, it's your y-intercept, plug the pieces in, you've got your answer. Hope that's helpful. Message me anytime with questions.